Check we're recording. We're recording. Okay, all right, everybody. So as we're moving out of our Python environment, we're going to be having a look at a different environment today. I am, for the first time in this session, using a PowerPoint slideshow rather than a Python notebook. Our Python notebooks have served us well thus far, but as we're moving from Python to C#, a different language, and indeed today we'll have a look at some of the syntax differences between those two languages. It could be good for you to see how the same concepts you've done in Python, we've looked at so far, how they map to Unity. So let me see, we'll point those out and let me see if I can just set this up. How am I going to set this up without showing the... I might not be able to use the full slideshow because that might potentially lose the sticky. Should we have a look at that, see if that works? Do we maintain the... we lose the sticky, don't we? Okay, all right. Well, let's go back to our standard view. Hopefully that's big enough. Take it you guys can see that. I'll lose my attendance code if I go full screen. I hope we can see that. Let me try and make that as small as possible. Okay, all right. Well, trust we can see that. Good. Okay, all right. So we're moving on to have a look at a different game, Super Mario. I'm assuming most of you have played Super Mario. Is anybody here not played Super Mario? Any of the games? None of the games at all? Wow, okay, that's surprising. Maybe there are a few. Okay, well, it's gone through a big evolution, has Super Mario, all the way back from NES and SNES back in the late 80s. And indeed, that's what we're going to have a look at today, the earliest 2D form of Super Mario. And then I remember this on the Game Boy Pocket when it came out in 1989. Black and white, yeah, classic. And then the subsequent color Game Boys, the other versions of Super Mario. Oh yes, this is millennials. It's what we grew up with. Pokemon, oh, it was a glorious time. Oh, I'm feeling great thinking about it. Yeah, 90s was a glorious decade. Lots of Super Mario Evolution through to Nintendo 64. First 3D Mario, N64. Has anyone played N64? The millennials amongst us, yes, I'm a millennial too. So yeah, the rest of you might be familiar with more recent versions of Mario, GameCube, I remember that, Sunshine, wasn't it? And then Galaxy, I think, the Wii, and lots of others. That's probably your generation, isn't it, after that? And what's the latest version of Mario these days? Odyssey. Ah, okay. So you're probably more familiar with later versions of it, but I remember some of the early versions. So anyway, it's a classic game. Most of you know it, so I thought it'd be good for us to have a look at it. All right. So if you've never ever played any of the games, here's a little illustration of one of them. This is from the one of the original ones. It's either the NES or the SNES. I think it might be the NES. For those who have played it before, what are some of the key behaviors, some of the key patterns of Mario? What do you observe from having a look at this? Shout it out. Yeah, go on. Power-ups. Okay, that's good, isn't it? Yeah, so Mario starts as a very small version of Mario, has a mushroom, grows in size, yeah, and then we even see in that little illustration there was, if I can run it again, if we get the frame rate back, he has a little sort of flower there to get fireballs, doesn't he? Throws fireballs at things. So 3 levels of power-up, yeah, that's good. When we hit the question block, there, question mark box, that's a power-up. Okay, what else do we notice? Camera. Okay, camera's good, yeah, and helpfully Unity has a camera mode that we can use. Not impossible to do in other situations. You could model that in Pygame. You just have to be a little bit more clever about how you move coordinates. Essentially, the camera is moving with Mario. We seem to have stalled. Oh, we're back again. Maybe it's the frame rate of this. Yeah, so the camera tracks Mario's position, doesn't it? It moves right. So remember what we said about x coordinates? If we move right, how does that change our x position? Increases x, very good. Yeah, so we saw that with Space Invaders, didn't we? Our player at the bottom, we increased the x position to go further towards the end of the screen. Same principle would apply here. The x values are going to increase as Mario moves right. And actually the camera doesn't go back, it doesn't regress, does it? It's not an open world, it can't go left once the camera's sort of stopped on that position. We seem to keep getting stuck at this point. Yeah, it will move right with Mario, but it doesn't go back as Mario goes left. So that's, if you were building this manually, something to think about, how you'd map that. Okay, good, camera. What else can we observe about this? A little bit louder, Bradley. Yeah, it's picked up the pickups. Yeah, very important. Yes, that's important. That's going to be another form of collision, isn't it? We saw collisions in Space Invaders, so we've got collisions again here. Mario is just about to jump on a Goomba. Yes. Enemies. Okay, very good. Yes, so that's important, isn't it? Goombas and Koopas are forms of opposition to Mario, aren't they? Forms of enemy. If Mario hits them, he either loses a life or downgrades. If he was large Mario, he's going to go down a level. Yes, so that's important. That's a form of collision, isn't it? That event is triggered upon the collision, so we can be factoring this in. Very good. What else can we tell about the style of graphics in this very primitive 2D form? What could we model this as? Okay, yeah, so pixels, yeah, and remember what we did in Space Invaders? We had a 2D array, didn't we? So we could potentially model it like that if we were building this from scratch. With Unity, we're going to focus on that environment today. We have a tile map. So that is essentially mapping out these coordinates. But yes, we could treat these as tiles, couldn't we? As squares, as elements of like a 2D array. Essentially, that's what's going on. And we'll have a look at some of the tile maps, and you'll see that. Index positions, again, remember. Where do the indices start? Or where did they start in Pygame? Where is 0, 0 on this map? Oh, do we think it's bottom left? Or we just say... yeah, in Pygame it was top left, wasn't it? It was top left. We'll have to check whether that's the case in Unity, whether it's got negative coordinates. I think it has negative coordinates as well, doesn't it? So 0, 0 might be center in Unity. So that's just something to pay attention to. Yeah, so it depends on your environment. But yeah, as you go further right, at least the X values will increase. Go further left, they decrease. Same again with Y and negative as well. So I think 0, 0 is center in Unity. But in Pygame, yes, it would be top left if you were modeling it there. Okay, so yeah, just something to translate to. Is there anything else we missed? I think we kind of got the basics, didn't we, with this? A time limit, I suppose you could say, technically. That's a form of opposition, isn't it? We have to complete the level, get to the end of the tile map within that time, don't we? Points, we collect coins as we go. We've got, there was one other key feature we missed, wasn't there? What about the physics of this game? Because with our Space Invaders, we stayed on the same Y position, didn't we? But what does Mario do? Yeah, so the fireballs will, you're correct, the fireballs will kind of bounce, won't they? Very true. So yeah. We got jump as well. That was the word I was looking for. So both a form of physics, aren't they? Because they model the concept of gravity. As things go up, they come down. So as Mario jumps, he doesn't just keep going off into space, he comes down as well, doesn't he? Ah, yeah, he sort of skids, doesn't he, as well? Yeah, and you're right, it could be a diagonal jump. It might not be a jump straight up and down, move the Y-axis. It could be like a diagonal jump. I think in the original version, he skids, doesn't he? He kind of like skids towards the end and stops slowly. Sorry, guys. So we've actually got a little bit more physics going on here, haven't we? Modelling gravity, modelling sort of friction, the skidding towards the end. The good news for you guys, of course, if you use Unity, is there's a lot of physics built in. So we don't have to do all the complex maths to solve this out. I mean, you could do, if you're up for a challenge, map it out yourselves. But thankfully, we can make use of a lot of the inbuilt physics within the Unity framework. So that is actually quite helpful too. That's going to help us and reduce the amount of coding we have to do. There's a little bit of coding we'll have to do, especially with jumping. We will have to factor that in, press space to jump, obviously, and then to come back down. We'll have to make sure the gravity scale is correct, whether it's how much he jumps, how fast he jumps, how heavy the gravity is, but that's a parameter we can set. So yeah, jumping, fireballs as well when we get to them. So that's a key thing, isn't it? And I think it's a single jump in this form. I remember in the Mario 64 he has double jumps and triple jumps, doesn't he? But I think it's a single jump in this case. You have to navigate the levels, don't we? Yeah. And also gravity on the blocks. He doesn't want to fall through the blocks or the floor. That's a common mistake you can make. So if you're modelling the floor, make sure he can't fall through it. Obviously, if there's gaps in the floor, that would need to be modelled. But we'd have to build in some sort of collision detection for the blocks, so that A, he doesn't go through the blocks when he's trying to jump up a level, and he doesn't fall through the floor either. So we've got to factor in those collisions there too. Okay. Did we get everything? I think we kind of got most of that, so that's good. We covered the camera, the gravity effective jump, power-ups you mentioned, very good, Goombas, time limits. So I think we've kind of mapped out most of the key behavior of Mario, to be honest. A little bit more of animations, I suppose we could have mentioned. A little bit more animated is Mario and all the players in there. With Space Invaders, you could have had a little bit of animation as the aliens move across the screen. The actual defender doesn't change that much as he moves across the screen. But with Mario, he does. Also, when he jumps on a Goomba, he's going to flatten the Goomba. So we might have to think about how we swap out the sprites and how we animate the sprites, potentially, if we wanted to model this type of game. Potentially in your games, as you think about this, you'll have to think about how you model sprites, if you're going to do animations, that is. So that's something worth thinking about too. Okay, so we've kind of scoped out some of the key behaviors, some of the key requirements. That's a good place to start, isn't it? And hopefully you're doing that with your game. Hopefully you've got a set of requirements now. If you haven't, you should probably write them down, because otherwise how will you keep a track of how well you've built your game? You should probably write them down and probably map against them. Okay, that's always a good place to start. It could even change as your game progresses. You might have missed something at the start that you need to go back and add. Could happen, happens in life. So make sure you write them down, document them. It's important. We want to model that process. Okay, document your requirements. I've just noted them here. Better if we write them up in good sentences. Like Mario should be able to move right. Mario should be able to jump, things like that. But I've just written them down in note form as we collect them. Okay, but once we've got our requirements, we could start to think about design, couldn't we? And we mentioned the 2D array format here, didn't we? Essentially, a level could be this very long 2D array. And indeed, that's how they did originally build these games. So if you're familiar, let me see if I can zoom in. This is one of the original tile maps from an earlier form of Super Mario Bros. And you can see all the squares, tiles, blocks. Essentially, we do have a 2D array here. Bit of hexadecimal too, as well. And you can see it coloured as well. So that's how they would have built it. They just built this huge 2D tiling array here. And you can tell some of the original notes as well. You might have already done something like that. Potentially, if you're doing this style of game, you might have got level design already. I've been looking around, I see a few of you have, which is fantastic, because that's going to guide how you then translate that into your environment, whether that's Unity, whether that's Pygame, whether that's something else. All right, so that's a good place to start, is scoping out what should the level look like. And indeed, that's exactly what they did. They went on to build this. Hopefully you can see this, the little squares, they mapped it all out. Where the coins are, you can just tell the outline of the Goombas there, the Koopa there, and all the different walls and tunnels potentially in other levels. But yes, they actually painstakingly mapped out the entire level. And as we said about the camera starts in one position and just steadily moves along the level to reveal more of this. That's probably an easier way to do it rather than writing the level as you move, as you've got to create a lot of squares as you move along. Not impossible, but it might be easier just to map them all out first, especially because they're static. You know, they don't change, the levels don't change every time you run the game. The Goombas always appear in the same places, the walls always appear in the same places, so it makes sense just to map it all out, this very long 2D array, so that you can then navigate it via the camera, as we see happening here. Okay, so as Mario moves right, we're going to steadily move the camera along. And the good news in Unity is that there's an object that we can do that quite easily with, the main camera. So that's, again, going to make things easier for us, make our life easier. Okay, So that's a paper design. You might have started with that. Indeed, these guys did back in the day. We're going back to the 80s and the 90s here. So pre-Adobe days of actually writing it out and then translating that. Very, very old school. But in a digital age, you might well do it digitally. You might well actually just write this out. And here we go. Here's a form of that built as a tile map. And you can tell that actually 0, 0 is built in this tile map to be top left. You can tell there, 0, 0. And then as we go down, we've got 2 blocks of tiles there for the bottom. And then all the background stuff is added in. Potentially we need to think about layers as well, don't we, here? Because we've got the kind of hills in the background, and then we've got the blocks and the tunnels in the foreground. So Mario wants to collide with these rather than these. Likewise, the sky, the clouds as well in the background, and things in the foreground. So you might want to think about layering as we do this. But yes, we could essentially build this out. Lots of you have done this. If you're using tile maps, fantastic. And then we simply have to create that in our environment. So good to have this as a design. Indeed, you might well be able to reuse that in future environments as well. So always good to document what you're doing. Always good to document your initial designs. All right. But yes, essentially it is a 2D array. That's essentially what we're saying. So those principles we've talked about are here too. That's the good news. It's just a case of how we implement them. So we could start to think about how we could translate some of this. As I say, some of this is made easier for us in our Unity environment. If you're going to try and recreate it in Pygame, it's slightly different. But in Unity, it lends itself better to this type of game. Camera is going to be made easier because we can just drop a camera object on a player, move that across. Gravity, there's an inbuilt gravity thing we could do, but also if we were running this in Pygame or something else, we'd have to think about increasing Y and then decreasing Y. If we're doing diagonal, we have to increase Y and X, and then also come down as we come down at an angle. Okay. Collisions is going to be important when we model this in Unity, because, like I said, we want to make sure he collides and simulates the game appropriately. It doesn't want to fall through the floor, and likewise doesn't want to be able to move through other blocks as well. So we just need to make sure we've got collision detection on all the various pieces in the foreground. Again, we'll show you how to do that in Unity. Okay, but that's that there. We mentioned the 2D array. That's essentially our tile map that we could build out, and do that in Unity fairly easily if we've got some assets. Indeed, I'll borrow some assets for us to use from the classic game. You might even create your own assets. Indeed, I think some of you have, which is brilliant. But those could be just tiled out along the line for the ground, for the foreground, etc. We've got that there too. Moving right, yeah, essentially we said that was the x-axis, didn't we? X-axis, increase the value of x from 0 to move right, decrease to move left. Okay, so all the same principles you've seen before. We're just building our intuition as we go throughout this, okay? All right, so do you remember this from a few weeks ago? We had a look at this, the Mario pyramid. If you had a go at this during the NumPy session, did anybody have a go at this during NumPy? Oh, okay. How did you go about building this pyramid?
Just set an array that was empty and then filled each line with 1, and then I made it x. And then I made x1. So the first line fills with 1, and then the next line I add 1 x, and then made it full.
Has to increase, doesn't it? That's the pattern here. You're right. If we did want to model this, as you mentioned, we could model this as a 2D array. That's indeed a good way of doing this. Remember, it's the same principle. Here that we have columns and rows. We could have something like this, okay? And essentially it's just abstracted for the tile map, like we saw. We could potentially model that principle of, you could do it one way. You could start with one block and then add a block on the y-axis as you go, and technically it's decreasing as you get higher towards 0. Remember, 0, 0 is top left, so the y-axis could decrease, or likewise you could start on the x-axis and increase them every time as you go along. So there's a number of ways you could go about solving this. Indeed, you might want to break it down into one to start with, focus on one half. A good place to start is actually just drawing a 7 by 7 block and then seeing if you can cut it in half, essentially. Can you decrease one of the drawing angles as you go? Did you use a nested for loop to do that? Or did you use something different?
I think I did use
Nested for loop. Yes, it lends itself to that. Because do you remember what the inner loop refers to generally in a nested for loop, drawing a 2D array? How would that be explained? The nested for the inner loop of the two loops generally draws. No, it generally draws one of the rows. So if you flip that around, it will draw the columns. If we draw one row at a time as of one loop, so for each column, draw these squares, and then as we go up, we just have to take one off, don't we? So start one indent in, don't start at 0, start at 1, and then draw that. Again, another loop. Your outer loop would be the number of rows, wouldn't it? So the inner loop is one row, and then the outer loop is drawing many rows. Okay, that's a way you could automate it. That would be the kind of automation way. Potentially, like I said, if we were doing this ourselves, if we were just drawing this in this environment, we could just painstakingly draw the squares. There is actually a tiling process to make that a little bit easier. You don't have to keep dragging each square on individually, thankfully. For things like that, there is a way to automate that and make that longer, which is brilliant. But yes, if you were recreating this in Python, for example, indeed the exercise was in Python at that time, wasn't it? Or Greenfoot's, this is actually from Greenfoot, Java's version of this. We could actually draw that like this to create a Mario pyramid. Okay, so it's a good little exercise to kind of get you used to drawing arrays, drawing 2D arrays, finding your way around these coordinates, seeing if you could automate some of this. Okay, it's a good little exercise to do. Recommend it. All right, but as I say, in Unity, it does make it a little bit easier for us as we can sketch those out. Okay, all right, so there we go. That's building our intuition. Let's just think a little bit about design ahead of time. So refer to our old friends, object-oriented programming. Do you notice patterns in the behavior of Mario? Could some of these be described as classes, maybe? Would you say so? Is it wise to have a player class?
Sometimes you also play as Luigi, so...
Very good. Yeah, okay, so you can have an abstract player, couldn't you? And then a specialized one for Mario, a specialized one for Luigi. Yes, very good. Okay, yeah. Or even higher, it could abstract that to be sprites. As you will sometimes see in your environments, you have this very abstract higher up class, just generically a sprite, as indeed we refer to them in the gaming world as those, and then they have their own individual characteristics, don't they? But yes, that's a good place to start, yeah, when we think about design. And indeed, when we get to our scripting in C#, everything in C# is built as a class. Okay, so you'll get to see that, and you'll see the keyword class when we get to C#. All right, so, and indeed when you write the script, you'll assign it to the object too. So yes, it will take on that script. Very good, and blocks as well, we could potentially have, if they have characteristics. Probably the question mark is a little bit more animated, isn't it? Because once it's collided with, it produces something, a mushroom or the flower, potentially, or something else. So that's probably wise to build that in. That could be a specialist form of block as well, couldn't it? That could be a specialized block. And then here's a generic block or a brick. And then we've got the ground blocks, which again have their own sort of collision detection. We could do that, very good. Goombas potentially could have its own script. And think about, as one thing we could mention about, what about the direction of the Goombas? What's their sort of direction, if you can make that out? They collide with the tunnels, the tubes here. They move their x-axis, and they alternate when they hit at the edge, don't they? So potentially we could write a script for that. Upon collision, upon a Goomba collision, if it hits that, it has to change direction to go back or collide with each other. Or likewise, if it collides with Mario, it's going to take a life, isn't it? Or reduce his power if he's an evolved form of Mario, okay? So that could be a good script to write. So it might be worth having a class for our Goomba. There we go. Okay, so good to think about this ahead of time, having our own scripts for this, okay? And indeed, you're going to see that as we start to transition into Unity. Okay, so I think we've arrived. There we go, with our intuition built, with our sort of a handle on what this game involves, and of course translate that to your own games, as indeed you're doing. Hopefully you're thinking about the requirements, hopefully you're doing some initial design, and that's going to really help when it comes to actually implement this and think through the problems. Okay, so how many of you have used Unity before? Okay, all right, interesting. Hands up for those who haven't, but would like to. Oh, okay, that's a few of you. All right, well, that's good. All right, so this is probably going to be a good way to get started then, trying to recreate something that's already been mapped out. And indeed, there are lots of assets available. It's great to see lots of artists in the room who are drawing their own stuff. Brilliant, and that's fantastic, because you can bring those assets into your game to use them. So what we'll attempt to do is just model a subset of the game. I won't map out the entire thing, that would take a bit of time to do the entire level, but if we focused on a subset, like the initial square, that's probably a good place to start with actually just creating things from scratch. Okay, so that's where we're going to start with this. I've mapped out a few little steps that we can chart a course to. Okay, so the first step would be just populating the level. Start with level design. Indeed, some of the gamers here probably have a dedicated module in level design. It's a big thing, okay? We won't be able to do the entirety of the game or the first level because there's a lot of it, but obviously we need to start with the ground blocks. We've got two Y positions there, haven't we? We've got 2 rows essentially, and that's going to be anchored to the bottom of the screen, so we might as well start there. Okay, so let me just show you the slides that we have here, and then we'll try and transition into Unity and show you this live. That's the plan. So here we go. Things we have to consider. First of all, collecting the assets. So I'm going to make use of some pre-written assets because it's a well-known game and a well-written game, so make use of that. You could design them from scratch, of course, but we'd have to have those accessible within our Unity environments under the form of assets. That's generically what they're referred to. We also have to think a little bit about their pixel size, and if this will render in good resolution, you hopefully can tell I'm going to change the pixels per unit to be a dedicated number. I mean, that could be a constant, we could set that somewhere, but 16 here just to make it an appropriate scale. Okay, and you're going to see if you're new to the Unity environment, we've got this inspector window which gives us the ability to set these values. And actually, as you look at these, just to kind of bring in our programming knowledge here, what do these look like? If we've got a ground block, G, capital G, could be a class. Indeed, it could be a specialized form of block. Ground block as a class. It's textured, obviously. But we've got these attributes here, haven't we? Type, shape, sprite mode, pixels per unit, we set values for. What did we say those were in programming? You had your hand up. Did you want to say? You forgot what it is? Oh, no. Variables. Yeah, variables, aren't they? They could, in another environment, you would see these as variables. And indeed, remember, students have names, they have IDs, they have modules. It's the same principle. Our classes have attributes, and we got that here. The only difference is we got a GUI. Make it even easier for us. We can just set the values in a GUI. Just type them in. We don't have to say pixels per unit equals 16, like we do in our code. We can just write it in here. We will write some code, by the way, but just to let you know, that's what we can do. Okay, so I could just type in there, let's have these as 16, and then drag them on. So drag them onto my environment. There we go, got the first block. We've taken the step forward. There's our first block on this empty canvas, once we've set it up. Our first ground block, okay? And thankfully, I don't have to do this hundreds of times. I don't have to drag on lots and lots of blocks, because another attribute that we have is this draw mode, okay? This draw mode in our list of attributes will give us the ability to tile our ground blocks. We can tile them so that we can basically reproduce, if you've ever done this with your backgrounds and things on your laptops and that, you can tile something. But in the old days where you didn't have such large resolution, you might not fill up the entire screen of a screensaver, you'd have to tile it. So this is a way that you can produce to a specification a number of tiles. So if we select tiled there, we should then be able to reproduce the entirety of the ground block. And what did I set that to? Oh yeah, well we need a height of 2. That's our 2 rows, isn't it? Height of 2, it's another attribute we can set. And width, well, let's start with 20, just to have a subset of this. You know, we'll start small. Obviously, the full level will be quite long as you move along it, but let's start there. Let's start somewhere. Start with 20, just so that we can navigate along this. There we go. So that's what we've got so far. We've just got this ground block, okay? And then, of course, we could just populate that with other things. So what we've got here, we've got the pyramid to climb up. And again, that we'd best to start that same with the same pixel size, pixels per unit of 16, just to kind of set a constant here, that it's going to be of the same size as our blocks, just so we can view this as an array. And again, we can go to town with setting those parameters. All right, so we could set that. And of course, we have a Mario sprite, which again, 16 per unit, and drag that on to create that. Okay, so let's see if we can do this. Let's see if we can get something going. Right, so here's something I had earlier, but let's see if we can start from scratch. Let me see if we can do this from scratch. If it's going to run for me. So assuming you've installed Unity, you'd have to start there, obviously, to download it and install it. Let's see if we can run this. So my resolution is a little bit big, but we'll try new projects. Oh, I can minimize that as well. And there are actually a number of interesting things you could look at. There are a number of templates. So it's got 3D templates, it's got 2D templates. I think I'm just going to start with the most basic one, this 2D core. As it's a 2D game, obviously, some of you might be ambitious and want to go for the 3D games. I think in years past they used to have a sample game. Is it this one? Yeah, the 2D platformer micro game, which is not a million miles away from Mario, I will say, because it's a platformer. A little bit more textured. You get slightly different, slightly more update graphics, let's say. You could start there. That's probably got some good things you could learn from, indeed, if you're looking at how Unity works. You could start there for that, a little micro game. But just to show you right from scratch what you could do, let's start here with our completely empty game. What should we call this? Let's say a Monday demo, or Mario demo, Mario Monday. Mario Mondays, I like the sound of that. Mario Monday. Hey, Mario Monday. And where should we put this? Let's put this, where should I put it? I'll put it in documents now, if I can't put it in GitHub. There we go, that's satisfied. Ooh, how do I actually create the project? Enter, should we go on from there? Ooh, have I got enough screen estate to do this? That's annoying. Can I do this from scratch? Oh, it's right down there. No, not Excel. I need to go to the bottom. Enter. Come on. Oh, that's a pain. Oh, if I make it big screen? It just will not render it, will it? Down there. That's annoying. Edit. Paste. Go forwards. How do I else do this? Or maximize. Right, there we go, maximize, there we go, that did it. Create projects, that's all I wanted to get to, sorry about that. This is only a problem for my 800 by 600, so hopefully, there we go, Mario Monday, there we go, let's start there. So it should be a blank canvas. Ooh, it must have opened already, let's go back. So that's the hub view, and then we have the Unity view, which is loading. So once you've got it downloaded, should be a free install, so you should be able to get the basic version. I'm assuming there's probably a professional version as well for the gamers in industry, but we'll just start with the free tier version. It's just rendering a few things. And here we go. Here's our blank canvas. Okay, and we've got a folder structure, so it would be better to organize it in folders, obviously, as we go. That would be helpful for our organization. But let's just see if we can do some basics. So I've got some pre-prepared stuff like Mario sprites. I can make those available to you if you did want to have a go at recreating this. You're probably working on your own games, but just to show you what we could do, we could drag those, quite literally drag them in. Where should we start? Let's start with the ground block. Let's see if we can drag that in. Let's just make this a bit smaller. And let's drag in ground block, see if that will fit in there. There we go, there's our ground block. Remember, we had to set the pixel width. Let's see if we can do that. Pixels per unit, yeah, because 100 is going to be quite small. If we make it 16, hopefully that will appear on the screen for us. Yeah, okay, all right, well, let's save that then. There we go, there's our ground block. And can I zoom in? So it'd be better if I had a sort of snap to grid, but can I zoom in? Oh, okay, all right, we got that. So let's click on that, and let's see if we can move that up. Oh, if it will let me. Maybe it will let me move it manually. Okay, all right, we can't seem to move it manually. So let's see if we can just change it manually. Let's see if we can actually just set the position of it. Oh, there we go. Oh, that might help. So in this inspector view, that's our sort of GUI into the attributes of our block. Well, we've got the funny X position and Y position. Could we harmonize that? Can we just 0? Okay, so 0 is that center. Let's try 0, 0. Ah, so that is the center, interestingly. Okay, all right. So how many tile blocks have we got? Would have to be something like -7. Oh, close. Let's go -7 then. Oh, too much. -5, -4. Okay, that wasn't how I hoped it was going to be. Sort of got stuck in the middle, wasn't it? That's annoying. I can't drag and drop it. All right, well, let's see. It's not aligning with the grids. Maybe this is just a grid view. It's worth saying. Doesn't seem to want to fit with the actual. Oh, I know. I think 0 is the center, isn't it? So maybe if we go something like 0.5. I think 0 is the actual center of the square. Okay. So I've just had to manually set those. Potentially in a different environment, it might be a little bit more easier to use, or actually move these around. But remember that just that principle of getting started, we want to tile this, don't we? So rather than have to do this painstakingly manually every time, let's make our lives a little bit easier, and let's actually just tile this. So I'm going to go to draw mode. That's another one of our attributes that we've got, and let's select, we've got a category here, so these are probably enumerate types. Let's go for tiled. Okay. And we, not periodically, it's not a full rectangle. Oh, did we not set that? Where do we set that? Tile mode. The full rectangle. Mesh type. We have to find mesh type. Is that in here? Oh, there we go. I think it's that. Mesh type full rectangle. There we go. Let's see if we can save that. And do we then get a chance to draw its size? Not generated with full rectangle. Do I end up dragging that one on? Is this one a full rectangle? Let's see. Draw mode tiled. That's what I'm looking for. That's what I'm looking for. Okay, so let's see if we can delete that one. It's worth also pointing out that we have them loaded up on the scene on the left-hand side. Okay, so you see these are technically instances, aren't they? Bless you. They're instances of that same entity. If the entity is the ground block, then I'm creating a new instance of it, aren't I? Essentially, we've got two instances of the same asset here. All right, so we didn't need this one as we've moved on from it, so let's delete that. Okay, and it's at a funny position, but let's just see. Let's just see, what was my height? Height was 2, essentially. There we go. It's potentially changed the coordinates as well, hasn't it? But width, what should we go for? Something like 20. It's a little bit on the long side. If I could drag it across, that would be a little bit easier. But maybe should we try something like 15? Yeah, potentially we could play around with the offsets. There's like offsets there to change, isn't there? Let's go for something. Let's go for something so we can keep moving. 20. There we go. We'll play around with this. We'll set it up how we want it. But that's just showing you how you could get started with the floor. Okay, we've got our camera window here. So let's see if we can bring in something else. What else have we got? We've got Mario. Let's bring in Mario now. Start with the idle version of him, because remember we're going to animate him as he moves along. So we've got a few different versions of him. We've also got the kind of defeated Mario as well. We've got the jump Mario. We've got the running Mario. We've got lots of different versions of him. This could be built as a sprite sheet, potentially. Maybe some of you in industry have got a sprite sheet and you have to kind of split them up, you have to slice them up. Here they're separate images, so I'm going to switch the image in future to be able to make this animate. But let's just start with a small version. Start with small Mario. Okay, let's drag him on here too. Oh, there he is. Oh, actually I should have set the pixel size first, shouldn't I? So let's use the same pixel size there. He's a little bit small, isn't he? A little bit small. So, oh, there we go. We've resized him. That's helpful. Because it must be set to the class, essentially. if all instances of Mario have that pixel per unit. Okay, it's good for us to know. And there he is. Okay. And then finally, just some other things. Let's just have a few hard blocks. Let's also have that as well. Here we go. So just model a subset of this. It would take a bit of time to actually do the entirety of the level. Let's just start here with something small. Okay, yeah, let's save those as well. That must be saved. I think it's actually set to the metadata. And if you were to inspect the metadata, you'd probably get a long list of the attributes and their values. Essentially the class mapping here, wouldn't you? Get a long list of those things. If you were to have a look at the metadata, which I think is stored separately. I think it's actually in a Nava folder. But when we inspect the folder directory, you probably will see a meta file which contains those attribute names and those values. Okay, so let's drag that in. And well, let's have a small pyramid. So remember that thing I showed you before. Let's have a little pyramid. Let's make use of the tiling. And actually, I need to change this to be a rectangle. See if we can do that. Save it as well. Okay, and then let's have a little bit of tiling. Let's go to the draw mode. Tiled. Okay, let's have a small pyramid. We won't go too big. So it'll take a long time to do all the layers. Okay. Potentially we could have a script to automate this if we want to. But here, let's have something, let's go for 5, 3, and 1, I think. We'll go for that. 5, 3, and 1. So let's see if we can. Oh, we can't move it, can we? Okay, all right. Well, let's leave Mario there. He's colliding with currently. Okay, and then let's do the same thing here. Let's have draw mode tiled. Okay, let's go for 3. Ooh, can I offset this? Can I offset this? Let's have a think. Can we just get that? If we try moving it around, because it'd be nice if we could put it back in there. It might be my touchpad. It was a little bit easier on a mouse, I will say that. I was able to drag and drop previously. Can we change this? We can change this. I suppose we could just set it manually for now. Should we go? No, other way. Let's go lower. -1. -1. No. +1. Okay, well, let's go for something like 0.5 then. Yeah, something like that. Something like that. Let's not obsess too much about it. And then finally, just one at the top. There we go. So, all right, something very simple, just to get us started. It's not the ideal environment. And indeed, you notice I've got a lot of instances of those. It would be advantageous probably to group them into layers. And indeed, we could also tag them too. Maybe that's something we should also think about to start with. We could tag Mario as the player, because he is the player. Okay, ooh, time. Yeah, so we could tag Mario as the player. And even, remember I said about the background and the foreground? Because Mario's in the foreground, we could also set them to be a particular layer. We could think about that too if we need to. Okay, let's just quickly tag these two. So this is going to be just ground. And if I need to create something new, we just click on the plus. Let's have a ground layer. We don't obviously want to fall through the ground, so let's add that and then set it. There we go. And let's see if we can now select it. There we go, ground. And then finally blocks. Let's have a block tag as well. So let's just create one of those. Okay, so a lot of this is just getting set up with a level design. You may have already done this, which is fantastic. But just if you're brand new, this is probably a good place to start with just setting up a very simple subset of this. A little bit of manual setup, but we have something that resembles Mario. Oh, the ground has moved. Let's see what this renders like. Click on the that play button to actually render this, simulate what it would look like. With a little bit offset. I think it would be a little bit easier if I had a mouse. I could drag and drop things. But if you'll pardon this very primitive setup, we have something that resembles a level. It's not perfect, but we're getting there. Okay, so we could probably reposition things. If we had snap to grid, that would be helpful to get started with, but at least we've made a start. We've started somewhere. Okay, so do more of this to get your level design. And should we just see if we could just quickly make Mario move? I think that's our next thing on the agenda. If we take a bit of time to set up the level, doing a lot more of what I've started, we could then have a look at how could we get Mario to move. Oh, and here we go. Here's C#. Right, so we've arrived. Okay. Okay, C# scripts. How many of you have written C# before? Ooh, less people. Okay, all right, so maybe we should just describe it then. All right, so in assets, we can create a script, C# scripts. I don't think we have the option to write Python, so therefore we need to get on board with C#. So what is C#? Well, let's have a look at it. Okay, here we go. Here is a bit of C# script. This is going to be the script that we assign to our Mario, our player. And what do you notice about this? Let's focus in on line 5. Public class player. What did we write in Python to define a class? Did we use class as well? I think we did. Class student, remember? Class player, class invader, class defender. Whatever entity is class, isn't it? Yeah. So this is a class, all right? Something you've seen before. And brownie points if you can name what's going on here. Colon mono behavior. Go on, Bradley.
Does that mean that it's entirely, basically the script is only can be used for one asset?
Yeah, well, mono, yes, is one. You're correct. Yeah, it is. It is, yes. And I suppose you could say, yeah, it is intended for that. As a programming concept, though, object-oriented programming concept that's being modeled here. Go on. It is inheritance, yes. And do you remember how we did that in Python? How did we model inheritance in Python? It's the brackets, isn't it? Yes, so it would be child class, parent class in brackets. Here in C#, it's colon. It's a colon inheritance. Yes, so you're right. Add those two things together, yes. Player is a subclass of mono behavior, which must come from a higher collection. And one thing we should also say, using, what do you think that translates to in Python? What did we write in Python? Import, very good, yes. So we've got the same thing. We're importing things. We are using these classes, these frameworks, use the Unity engine and make use of the collections. That's something you typically see in C#. System, that's where everything resides. That's the starting place. Use the system. Okay, same as import SYS in Python. So it's the same concept, it's just translated differently. Okay. And notice we've got curly code braces. So with your classes and your functions, you need a pair of curly code braces. You need semicolons, okay? You had it good in Python. Python was kind to you, but in C# you're going to need to be quite specific, okay? You're going to need to type things out statically. Okay, and we got, you know what a floating point variable is, don't you? You've seen those before. Decimals, yeah, floating. But here we've actually explicitly defined it to be float. So we need types in C#. Okay, so can't just say move speed equals. I have to say it's a float. It's a floating point number. You have to scope it to that. Assign some memory for it. F essentially is just treating this as a float, because remember in Python, 5 on its own would be inferred as an integer. Very good. So we're actually defining this as 5, but in floating point form. Don't confuse it with an integer. It's probably going to tell you off if you try and assign an integer to this. So treat it as a float so it can be stored in a float variable. Very good. Okay. And we also have another keyword here, don't we? Again, brownie points, those who know their OO. We kind of saw this in stealth in Python. Anyone know what public refers to? Global, in the sense of, expand upon that. Yes, it is a global variable, yeah, and the classes too. Okay, so it's accessible outside of this class, is what we're saying. You remember in Python, we could just refer to attributes of an object without having to get them. We could just access them straight through the object name. Essentially, we'd be able to do that here if we declare it to be public. In Python, it's implicitly public. We might start with private, though. If it's private, it's only accessible and viewable and modifiable inside this class. So that's where we have these things called getters and setters. You may have come across that language, getters and setters, okay? Where you can set the values in that class and also return them so other classes can look at them as well or get access to them. It's basically just interfacing. It's putting an interface, trying to protect things, keep them behind an interface. Okay, that actually models another principle of OO. Again, brownie points. Does anyone know what that refers to? It's a long word. Maybe this is too stretching of a question. Well, you know one of the principles, don't you? Inheritance of object orientation. There's actually another principle that's modeled here. Yeah, no, I didn't tell you about it, so that's fine. It's encapsulation. So it's another OO principle of this. Public, private is also protected as well. That's encapsulation, essentially. Encapsulated within a class. All right, so just pointing things out. Void, and actually our functions, notice a few things here. Our functions starts with actually capitals. So it's a stylistic difference, isn't it? Remember I said in Python our classes start with capital letters. Here in C#, our functions start with capital letters as well. Just pointing out differences between them. Anyone know what void refers to? Doesn't have a return. Very good, yes. So in Python we didn't have to write that, did we? We just said define this function. In C#, we have to have a return type. So void here, nothing's being returned. If something was being returned, if you have a return keyword, you actually have to write the type of data, and they just have to match. So here there's no return statement, so it's void. In here there's also no return statement, so it's void as well. Okay, so just there's a lot more syntax with C#, hence why I took it easy on you to start with. With Python, it gets a little bit more wordy in other languages, okay? And then we've got a few other things going on here. Ooh, let's stretch you again. What's going on here? You don't have to know technically what vector 3 is. Well, okay, yes, it will, and indeed that's what we're saying. But again, in our programming context, if vector 3 is the class name, what is a method that has the same name as the class? What did we say that was in Python? It builds the object, it instantiates the object. Something that is being built is being... Yes, it's a constructor. It's the constructor, isn't it? Yes, it's the constructor. Method, same name as the class. Call the constructor. You do this, like you say student. Student returns an object. Same thing going on here. You call the constructor. What are you doing? You're passing in these variables, horizontal movement, floats, and also multiplying it as well by these other variables that we've got going on. Very good. Okay. And then we've got here class name. Movement is the object. So movement's your object. New is another keyword you need for C#, because that is basically a call to assign that memory on the heap. If you do algorithms and data structures with me next year, we dive into that and have a look at the difference between how memory is assigned. In C#, we can be a lot more specific with where that memory is assigned. Essentially, we just need a larger store of memory, put this object on that store of memory, which is the heap, okay? So yes, that is how we create objects in C#. Okay, you need to follow this format. It's no longer just class name and return the object, it's class name, object name equals new constructor. More wordy, okay, but it's the same concept. Same concept, you know this, don't you, plus equals, and it's of the transform object, which must be referred to here, so that must be built somewhere else, but yes, it is an object, dot position, increase that attribute's value by movement, which essentially, as Bradley was saying, what we actually trying to do by all this, well, we're trying to move. Okay, that's what's going on there. Okay, so that once we build this as a script, assign it to Mario, we can do that via add components. We've got this C# script player, that's the player script. We are then able to move Mario around. Okay, I've run out of time to show you that, but don't worry, we've got part 2 tomorrow. So if you want more of this, come back tomorrow and I'll show you how to do that. But there we go, there's your intro to Unity. Part 2 is coming up tomorrow. All right.